I began my career as an applied mathematician, and around the time in the 1990s when the big dream in the pharmaceutical industry was how to get, protein therapeutics into the bloodstream without having to inject them. It had been determined by the time I showed up that the best way of all the different ways you could imagine of getting proteins into the blood would be to breathe them into your lungs and breathe them deeply into the lungs in a way that was not possible with the existing asthma technology at the time. So this led to, so I published an article in Science in 1997 showing that if you designed insulin to look like a wiffle ball particle rather than the droplets and particles that people had used for delivering drugs before, you could actually deliver them really efficiently into the lungs with very simple devices. And it led to a company, which is really shocking to me. I'd never imagined myself doing that. I started it with a few friends at MIT, and it sold within 13 months, and it was really big event in our lives, obviously. It took a while for that to come out on the market. It took 18 years to come out of the market, and it came out when it did as inhaled L-DOPA, Inbrija, for treatment of Parkinson's, and that's what the inhaler looks like. I had a couple friends at Harvard University in the School of Engineering and Applied Science, or the division at the time, who came to see me and said that the dean at the time, Venki Narayanamurthy, was interested to talk. And so I sat down with all of them, and there was at that time a very theoretical culture in the engineering school here at Harvard, and an interest to emulate some of what was going on down the street at MIT, where in the late 90s they were doing really, really well. And because I had been a theory guy, they thought maybe I would have some insight there. And so I was really interested in this, partly because I didn't really understand myself how this had happened. I had not dreamed of starting a company, and in fact, I had an audience of about 10 people before this all started. It seemed intuitive to me that a woman who I came to know really well at MIT, Anita Desai, the novelist, was part of what happened in my brain. And so I had been writing fiction for years, and it had been just something I did on the side, as many scientists have artistic activities on the side. Coming to Harvard, I thought, well, I'd never been at a liberal arts college before, and I thought, well, we have here artists and scientists, and so there must be people talking. It was funny when I came, Larry Summers was the president and was organizing these complexity meetings, because in fact what was going on was you had a lot of artists and scientists, or at least humanities and science folks and engineers, but they were siloed and the conversations were not happening. And so these complexity meetings brought them all together, which I thought would be really fun to experience. It was interesting to me that in those meetings there were engineers and medical doctors and even philosophers, but there weren't really music professors and other kinds of liberal arts disciplines that were further afield. And so I started a conversation with many faculty, including Kay, who was here yesterday, and Doris, and it led to a book called Art Science. I was really intrigued that all of us were creating in our lives kinds of labs that were encouraging us to interdisciplinary activity that our institutions were not, and were in fact rewarding us. And it intrigued me that this lab might actually exist in reality. And so I went to Paris and I opened the lab, the laboratoire, in 2005. And so we speak French at home, and it seemed to me that it was important that the lab be artistic in its expression, even though scientific in its process. And that the audience needed to be not a peer-reviewed audience, but actually the public that was actually willingly and interestingly engaging in the process. This led to another book and to a lot of students coming from Harvard, and both in the School of Design and the engineering school, and we learned a lot. And so my experience at Harvard kind of came to an end with a book that I published, Creating Things That Matter, which won a National Book Award, and really articulates that story. Personally, in all of this, I was interested about thinking about breathing differently. So that's what I do scientifically. And as we all have probably noticed, the air has become toxic. So one of the cruel realities that we face today is that the very act of breathing is killing us. If you look at the numbers, you can argue that we're losing something between 1 to 10 years of life by breathing dirty air. And it's not just the fact that the air is dirty, it's also the fact that it's dry. It turns out that if you can have people breathing pretty much the air that our pre-ancestors breathed. Pretty warm, pretty humid, pretty salty air. Pretty sedentary people not breathing as much air as we do. Your airways are designed to clean the air you breathe and hydrate it. But when you dry out, as we are really all pretty chronically dried out, that fails, and suddenly all respiratory diseases worsen. The issue, of course, is that the air continues to get dirtier. And you might think, well, here in this country and in Europe, we've cleaned up the air a lot, but the reality is that the little particles that make us sick rise up into the stratosphere and go around the world. And so as the world industrializes, we all begin to breathe the same dirty air. And what's also true, of course, is that it's not fairly distributed clean air. The people who are the poorest on the planet are the people who are breathing the dirtiest air, and there are some just astounding and horrific statistics, including this one, that black children in this country are 4 times more likely to die of asthma than non-blacks. We have some articles appearing tomorrow in the Boston Hospitality Magazine showing that there's actually quite an overlap between the inequity of clean air and the inequity of good nutrition. So over these years, I've been exploring artistically ways to breathe differently. And the issue here is that there are not that many pharmaceutical companies and that much money for all of us to be breathing differently by virtue of pharmaceutical drugs. We need to create ways that are accessible to everybody, and for those to be not only accessible but actually used, they have to be beautiful. In other words, if you're changing your behavior, it has to be something that you want to do, particularly if you're going to be doing it every day. And so we've really played a lot with different kinds of ways of breathing beautiful things, if you will, over the many years. Now, in parallel, we've been, and I've been really deeply in looking at the science of breathing differently, and it began with the anthrax scare. In 2001, I had, in a way, weaponized insulin, and there was an interest to understand how do we prevent bioterrorists from weaponizing things like anthrax. And this led to pretty much a conclusion that we can't, but that we might be able to put something in the lungs that would protect us all. And so we showed in 2004 in PNAS that if you put salt water in the airways, you can get rid of these little respiratory droplets that we know and hear a lot about these days. And so we continued that science for many years, didn't publish a lot of it until the pandemic hit. And when that happened, took the data to Janet Woodcock, who leads the drug division at the FDA, and shared the data. Because salts, when you breathe them through the nose, can be regulated in this country as a cosmetic, like soap, we could get right into people. And so we began to actually publish a lot of clinical work and brought out a new form of hygiene that we've been selling here in this country for the last 2 years. The clinical trials have continued, and right now we have some major trials going on in this country, in the UK, and in India. And our goal here is to show that by the daily hydration of your upper airways with divalent salts. So these are salts that are in your body, but they actually hang in there longer than the normal table salt will. So you can hydrate for several hours, so 3 hydrations a day, and you're hydrated for 24 hours. We're attempting to determine whether we can not only treat some acute respiratory disease like chronic cough, but also lower the airway inflammation that those of us who are breathing dirty air have by virtue of the dirty air, and therefore relieve the burden of chronic respiratory disease. So the math is really, really interesting here, because salt and water are very accessible, obviously, and if you do the if you look at the economics here, it takes about $500 to hydrate a person's airways every day for 50 years. And if it's true, the data that actually goes back to this Harvard 6-city study that was published 30 years ago, that we're losing up to 10 years of life in the dirtiest air places, we can maybe save 2 years of life for about $500. So my conclusion is that science can show us what to do on a planet where the survival of humanity is not obvious, but I'm pretty convinced that it will take artists to get us to do it. So that's it, and I'll just finish by saying that for me, cultural agency, which is such an incredible term, has been a life experience, and it's really been echoed by so many things that you've all said. Thank you.